Our goal is to find a solution for this augmented matrix. If you want to convert this back into a system of linear equation, it's going to be 2x plus y minus z equals to 3, and then 1x minus 1y plus 1z equals to 0, 0x plus y plus 2z equals to 1. So remember that your goal, your job is to write this in the format that you have 1 as the leading coefficient, then some numerical values, 0 below 1, some other numerical values, another 0 below 0, the rest of the numerical values, and then this guy must be equal to 1. Below 1, you must have 0, and finally, on the main diagonal, you need to see all 1s. And below 1s, you need to see 0s. So let's try. I'm looking at R1 and R2, the first row and the second row. So I'm going to interchange these two rows. Interchange R1 and R2. This guy becomes the following. 1, negative 1, 1, and 0. You have a 2, you have a 1, you have a negative 1, and 3 goes here. And then you have a 0, 1, 2, 1. And I say, hey, I have a 0 on this row. Why not interchanging R2 and R3? Let's do that. Interchange R2 and R3. So this guy becomes the following. 1, negative 1, 1, 0, and then interchanging these two, 0, 1, 2, and 1, and then you have 2, 1, negative 1, and 3. Perfect. Now you're going to make this guy equal to 0. Always look back to the form that you're going to try to create. This is 2, which must be 0. So what I can do, I can multiply the very first row by negative 2 and add it to the last row. So negative R1 plus R3, which replaced for R3. So I have negative 2. Okay. So I have negative 2, and you have positive 2, negative 2, 0, plus R3, which is 2, 1, negative 1, and then 3. So if I add this together, it becomes 0, 3, negative 3, and then 3. Okay, this is going to be your last row. Let's copy down the very first two rows, 1, negative 1, 1, and then 0, then 0, 1, 2, 1, and then your new last row is 0, 3, negative 3, and 3. Okay, so far so good. We're good with the first column. My first columns are basically the same. Now I'm going to move to the second column. For the second column, I need to see 1 on the main diagonal, which is, but below that, I need to see 0. Well, you could divide the last row by 3, or you can multiply the second row by negative 3 and add it to the last row. So negative 3 times R2 plus R3 replaced for R3. So I have a 0, negative 3, then I have a negative 6, and negative 3 plus 0, 3, negative 3, and then 3. This guy becomes 0, 0, negative 9, and 0. Very good. So my new matrix is 1, negative 1, 1, and then 0. My second row stays the same, 0, 1, 2, 1. And my last row is 0, 0, negative 9, and 0. So we only left with this last row here. So far everything looks similar. This guy must be equal to 1, but you have a negative 9. We're going to divide the last row by negative 9, or multiply that by negative 1 over 9 times R3, and this guy is going to be your new R3. I have 1, negative 1, 1, and 0, 0, 1, 2, 1, 0, 0, 1, and 0. Now let us start solving the system of equations, which is equivalent to the original system of equations. So again, you can rewrite this in the form of a system of equations. You have x minus y plus z equal to 0. You have y plus 2z equals to 1. Then you have 0x plus 0y plus z equal to 0. So as you can see, your z is equal to 0. Replace that into the second equation, y becomes 1. So z is 0, y is 1. Enter these two in the first equation. X minus 1 plus 0 is 0, so x is 1. The intersection between these three planes is at this point. So these three planes intersect at the point 1, 1, and